Right. So for those who are joining asynchronously, welcome. We're going to do today we're going to go through some aspects of how to manage your research, and then we're going to look at more advanced skills. And let's dive in. What I'm gonna do now is, well, no, I'm not gonna share my screen because it's already being shared. So we've been using RStudio, but we haven't really been using RStudio in the sense that when you were running the tutorials, they were in their own window, and you were using data that was already loaded or attached to the session, and you were working within that environment of the tutorial itself. Today, instead, we're going to move to actually using RStudio more. The tutorials will still be like they were yesterday, but I want to show you how you can, use RStudio in an efficient way to organize your research. RStudio looks like this. You've seen it. You've seen it when you did your tutorials. You have in the top left corner the editor panel, where when you open a file, you'll be able to see the file and edit the file there. In the bottom left corner, there's the console. And you have seen the console already when you had to install packages, update packages. So that is where basically you can run command by typing them. And then on the right, you have at the top right, the environment tab. I might have actually mentioned this yesterday, but the environment tab lists all the data and the variables that you create and other objects that you create. So you can see actually in this particular session that you're running with RStudio, you can see what objects you have created. And then in the bottom right, you have several tabs as well. And the first one is the Files tab, which allows you to browse the files from basically the working directory. Today we're going to talk about working directories a little bit more, but as I mentioned yesterday, I'll give you some tips on how to make that easier for you. So you will not have to worry much about working directories. So what I would like to ask you to do now is to open your options, the options from RStudio. Let me show how that is done. I'm using macOS, and if you have Windows, it could be that the option menu is somewhere else, but I quite do not remember, so you have to bear with me with that, and hopefully you'll find it. But if you do have macOS, then from Tools, there's Global Options over there. You can, I think on Windows as well, if you do Control, comma, it should bring up your options. On macOS is Command, comma. I'm not sure whether it works on Windows, sorry for that. And once you open the Global Options, you have to make sure that the option for restore data into workspace at startup is not selected. Basically, when this is selected is every time you open RStudio, it brings up all the objects, all the variables and data and everything that you did in the previous session, and it restores that. There are two problems with this. First of all, sometimes we don't realize and we have a variable that has been saved in the workspace, and you open RStudio again, but in fact, you don't need that variable anymore. And you have some code that calls a variable that has exactly the same name. And for some reason, you forget actually to overwrite that particular variable. So it can happen that you run analyses on data or variables that are not the ones that you intended. And trust me, like it seems like impossible, but it does happen. And it did happen very frequently to me at the very beginning. and also to colleagues and friends that were started using our studio. They had, I'm not going to say every day, but every other day they would spend 10, 15 minutes try to understand why the thing didn't make sense, and then they would realize that they had like a hidden variable somewhere that was screwing up everything, basically. So I strongly recommend to deselect that option, restore our data, and then you never want, in fact, to save the workspace to a data file. So you want to select never for save workspace to our data on exit. You don't want to save the workspace exactly because you don't want the workspace to be reloaded every time you open RStudio. There are other better ways, more efficient ways for storing things and saving things, actually, than using this RData workspace file. So I do recommend saving objects yourself, saving, for example, data analysis outputs or plots or everything. I do recommend saving them individually so you have control over what you're saving. And I think that's it, basically, in terms of important options that you don't want to have on. You don't want to save the workspace, and you don't want to load it when you start RStudio again. And there we go. So let me go back there. Right, the most beautiful thing ever about RStudio is that you can create separate RStudio projects. A project, you can think of it as simply as a folder on your computer. And, we tend to do that already, sorry, in the sense that perhaps you're working on two projects at the same time, and perhaps you're teaching as well, so you have another folder with all of the materials for that particular course. So we're already used to work with separate folders for separate projects. RStudio can actually use a folder as a project, meaning that everything in that folder is contained within a particular R session, and whatever you do in that particular project doesn't affect what you do in other projects. And I do recommend actually using R projects, and I do in fact recommend having one RStudio project per project, meaning that you would have separate folders with files in it that belong to one particular project, and each will be an RStudio project. I can quickly show you how for example, my project folder looks like. Hope it's not too small, but what you see here is that I have for each project I'm working on, I have like a separate folder, and most of these are actually also RStudio projects. So every time I need to work on any one project, I go to that folder, and this file that ends with proj is what makes this folder an RStudio project. Like, it's nothing different from a folder. It's just that it has this file in it, then that makes that folder a RStudio project. And if you double click on that file, it's going to open up RStudio inside that project. So you can actually open different projects at the same time. So you can have your main project, RStudio project, opened, and then you realize that you need something from a different project. You can go to your folder, open a different RStudio window with that different project, then copy the code that you need, for example, from there into the other project. I do very much, again, recommend doing this, each project having its own environment, so to say, and having different projects, because it really makes it easier to work independently between one project and the other. And it's also easier than if you have to share data, if you have to share code with colleagues, or for example, if you're sharing your research data together with your paper. So again, I do recommend doing that. And the way you can create RStudio projects is twofold. So if you're creating a new project, you can click on this button over here. Let me show you actually on RStudio. Yeah, that's much better. So you see that sort of plus R sign. If you click on it, it asks you whether you want to create a project in a new directory or in an existing directory. Never mind version control for now. If you are creating a new project, you can click on new directory. So if you're starting a new project and you're intending of using R, I do recommend clicking on new directory. And then you click on new project, and it's going to ask you to give it a name that is could be the name of the project, and also it asks you to select a folder within which a folder will be created with the name you specify here, and that will be a project. So I actually invite everybody to try and do it now to create a new project. So let me show you again from plus R, the button in the top left corner. You click on new directory, new project, and then I'm gonna call it my new project. And I want that to be saved on my desktop. My suggestion from my heart is don't save things on the desktop, because then everything gets saved on the desktop and it becomes very messy. I learned that the hard way through the years. But for these purposes, I will save it. So for the purpose of today's tutorial workshop, I will save this on the desktop. For now, never mind, create a Git repository and use Renv with this project. You can untick them both. And since I already have a project, a RStudio project opened, you can click on opening new session, and then that will keep the current window, RStudio window, still functioning, and will open a new one for you. And then you can click on create project. And after a few seconds, here you are in your new RStudio project, and you know that you are because if you look here on the top right corner, there's the name of the project, right? In this case, it says my new project, and if you click, you have other options. You can create a new project, open an existing project, and there's also a list of other projects that you have opened. So it's very handy, and if you click on any of those, it's going to switch to that project. If you don't want to switch to the project, but you want to open the project in a separate window, you can just click on this tiny window with an arrow. It's going to open that RStudio project again in a separate window, and you can have as many as you wish open at the same time. Great. What else did I want to say? Right, so working directories. So we talked about working directories yesterday, and you can see your working directory by typing, and I do invite you to try that out, get WD, get working directory, open and close parentheses. This is a function that doesn't take any argument. And you can see that it gives you the full path to the folder of this particular RStudio project, which is my new project saved on my desktop, right? So you won't have to worry about working directories if you use RStudio projects, because with RStudio projects, the working directory is always going to be the project folder. So meaning that everything that you put inside that folder can be accessed from the main project folder. Trust me, that makes a lot of a difference. Having your RStudio project, you open the project, and then you're ready. Basically, from that folder, you know where to find your files, right? In fact, I do recommend having and I'll show you a bit more about this in a second. But I do recommend having all of the files that are related to a single project in the project folder, of course. So I invite you now to try and create a new folder inside your project folder. You can do that directly from within RStudio. You can create, and you can click on new folder, and let's call it data. And that will create a folder inside your project folder. If you navigate into the data folder by clicking on it in the files panel, you see that now it's empty, right? There's nothing there because we just created the folder. What we're going to do now is we're going to create a teeny tiny data table and save it in that folder, and then we're going to read it in. And to do that, you can just click on New File, top left corner, and you click on Text File. Once you click on Text File, you will see that a new empty file is created and opened in the editor panel. The file is not saved yet. It just exists in the hyperspace. It's not saved anywhere in your computer, which means that if you make some edits to the file and you close RStudio, it's gonna tell you made changes, should I save the file? So in general, it's very unlikely that you lose work, basically, unless RStudio crashes. It doesn't usually, so that's good to know. So you can now write in the untitled one file, and let's just create a 2-column, 2 rows data set. I'm gonna do the usual boring fruit because I can't think of anything else, and comma, because this will be a comma separated value file, and let's say quantity, and then I'm just gonna put apple. I have 3, and bananas, I have 1 only. So this is a very simple comma separated value file. You have fruit quantity, that's the heading or the header of the file. Those are going to be my 2 columns. And then you have 2 rows. I have 3 apples and 1 banana. Then you can click on save, and what you'll notice is that the file browser for saving the file will be opened already in your project folder. So we can click on data now, and we can call it fruit.csv. And then you can just save it, and it's going to be saved inside that folder. Perhaps we want to do this.
Nice.
So from there, you just save it inside that particular folder. And there you go. Now you can see it here. It's saved inside the data folder, and it shows up in the file browser again. Great. I'm just going to check whether we have some questions. No. If I'm going too quick, let me know and I can slow down. If I'm going too slow, you can tell me as well. So now that we have created this file, we're gonna read it in. But before doing that, I want to oh, well, I mean, I did say most of these things. So the advantages of using a RStudio project is that you can open and work on multiple projects at the same time. The files in each project are easily accessible by using relative paths, and we're going to see what that means in a second. And you can even isolate package dependencies. So if you need to install packages, but you need different packages that are not compatible with each other for different projects, you can actually isolate the packages you install within the project using our env. I'm not going to discuss this, but that is also an option. If you're familiar with Python, you know what the dependency hell is, meaning that there are cases where packages need other packages but need different versions, and sometimes the versions are not compatible with each other. So in order to use one package, you need a particular version of another one, but then another package that you use in another project needs a different version. This happens it doesn't really happen with R, differently from Python. R as a sort of centralized organization that controls the packages, basically, and ensures that all of the packages work well together. So, in fact, I don't think it ever happened to me that I had issues with our packages versions. But it makes it easier actually to deal with different packages if you isolate package dependencies. But that's sort of a more advanced skill that you can check out later. And then, of course, it simplifies, as I mentioned before, the distribution of your research, right? Because you just have that folder with the project and you can just give it away and people will be able to do everything without adjusting, for example, paths and so on. Disadvantage is none. Like there's really nothing that is a disadvantage that I could think of. And I've been using RStudio projects now for several years and they never failed to work well for everything that I was doing. Right, so now we have our studio project, we have created a file, and now we want to import the data. So far, you've been working either in the console or through the tutorial, meaning that you were running code inside boxes, clicking on the run code in the tutorial. That, of course, is not what you would normally do when you actually do data analysis. Instead, of course, you would have your own data and you would do things with that. And the best way of ensuring that you remember the analysis that you're conducting, and also that you make sure that other people can see what you did, and other people can really be colleagues or other people per se, other researchers, or even your future self, right? I do not recommend doing analysis just by running things in the console and then, for example, saving the plot. I think 100% of the times there will be occasions where you will have to make changes, for example, either to the plot or to the analysis. And if you go back, it's going to be very, very difficult to recreate exactly the same thing unless you have like an extremely acute memory. So instead, what we do is that we save the code in scripts. Scripts are just files, text files, where you write down the code that you use to perform a particular task. And for R, there are specific type of scripts. Those are called R scripts, and they are just files that end with the extension .r. And what we're going to do now is we're going to create a new R script, and we're going to write down the code to load the fruit dataset. So to do that, you click again on the plus sign over there, and this time you click on R script. That will open up again a untitled one script, and this time we're going to save it before we do anything else. So you can either click on the save thing or use the shortcuts on the keyboard. It's usually the same as with other programs. And this time, let's actually create a new folder called code inside our project. So actually, let me go back to column so you see what this looks like. So I have my my new project folder with the data folder and my data set that we're going to read in a second. And then in the code folder, I'm going to call this analysis, for example, .r. And now my R script is saved in the code folder, and you can find it there. Great. So we want to read a CSV file. We can use the tidyverse to read files. In most cases, you will be using CSV files or other delimited files with different delimiters, like tabs, for example. But let's stick to CSV files for now. So what you want to write in your analysis script is, of course, library tidyverse. Right, you can write library tidyverse because you need to attach the package, remember, in order to be able to use it. Somebody asked yesterday, I think perhaps I've already answered that, like if asked about this. So you install packages once and then you attach them every time you start an R session, which is every time you open RStudio. And I did mention, of course, you don't have to type all the time because you can use R scripts. And you can write the packages that you need at the beginning usually. So even if you need them later in the script, I usually just write them all at the beginning. And you can add more calls to the library function. And for example, I can call the fortunes package that we installed yesterday. Now, now you can actually run the script. There are, I think, at least 3 ways of doing this. Well, more, but let's talk about 3 ways. You can click on run here, and then that will run the current line or selection. So now I'm on the first line, library tidyverse. If I click on run, it's gonna run that line only. If I click on run again, now it's gonna run the second. You might have noticed that it moves automatically onto the next line. So you can click run again, and of course. Sorry again. Around 500 to 600. Sorry, was that a question? I can't hear you well. Right, no, perhaps just the microphone was turned on by mistake. So now here it says error, there is no package called fortunes for reasons that I'm not going to explain to you, but in your case, it should work fine if you installed it yesterday. But we don't need that, so I'm just going to leave library tidyverse for now. Another way you can run this. Let me check. Okay, another way you can run that is to use the shortcut on the keyboard. On macOS is Command Return, Command Enter, and that will run the current selection or the current line. Command Enter. You can see now that when I run it again, it doesn't say anything because the packages are already attached. So if you run library tidyverse again, nothing is going to happen. You're not going to see anything because you've already attached the packages. On Windows, it should be Control Return. Let me know if it works. It should be, yes, Control Enter or Control Return. And that's the way that I usually actually use when I run things from a script. I just go to the lines that I need to run, and I type Command Return several times per line. Or in most cases, I actually select the whole script and I click Command Return or Command Enter to run it. Yes, so somebody, thank you, is confirming that, or later, thanks, that it's Control Enter. So we have loaded the packages now, and now we can read the fruit file, and I'm gonna save it into a variable called fruit, and the function, if you remember from yesterday, is intuitively read CSV. And the first argument, and that's generally the only argument that you have to specify, is the file argument. You can see that it says also here in the tooltip the first argument is file. If you want to know, I did mention this yesterday, if you want to know more about any function, you can just write in the console !read_CSV, and that will open up the help here to the right. And at the beginning, it might feel a bit daunting understanding the documentation, but after some time you start, like, generally the documentation is structured in the same way for every function. So after some time you actually know where to go within a particular documentation of a function to search for information for that particular function. But if you want to know what the arguments are for a particular function, you can look at usage, and it lists all of the arguments and also the defaults. Some arguments might have a default, which means that if you don't specify them, they will have the default value. You can see here that in, well, let's do read CSV, file doesn't have a default, right? Call names has a default, which is true, but file doesn't, which means that you have to specify it every time you use the function, right? So that's basically how it works. So now I did mention that sometimes you need to check your working directory, but then I said that if you're using RStudio projects, you don't have to do that because it's always going to be the folder of the project. So now we want to read the file that is inside the data folder, and the data folder is in the top level folder that is called. The top level folder is the topmost folder of the project that contains all of the other files, right? So if I type, in fact, data there, and then you press tab, sorry, / and then you press tab, usually you will see a list of files in that particular folder. In this case, there's only one, so it just directly gave me fruit.csv, right? Let me show you again. You can also do it from there. Remember that file paths are strings, so they need to be double quoted. If you just have the 2 quotes and you press tab, it's going to come up with the folders in your project, right? So this is also why it's handy to use RStudio projects. And you can either click or move with your arrows from the keyboard. I'm using my bottom, my up and down arrow. Then you can select the folder that you need to go to. You press tab again. Then now it tells me there's fruit.csv, and you can press enter. So this is called a relative path. It's called a relative path because it's relative to the working directory, right? The working directory is the project directory, which is my new project. So I don't have to write the full path to this particular folder. I can start the path from the project folder, right? And trust me, this makes life way, way easier. Now I can simply run this code, read CSV, and that will read in the file. And you see that you've done that up here, because now there's the fruit data with 2 observations and 2 variables. And again, if you click on it, you're going to see that it's opened in the file editor. Sorry, right. So now we're writing a R script. It's important that R scripts are standalone, meaning that you can run them from start to finish without errors or without having to run something else manually, for example. Make sure that when you write R scripts, that they can just be run from start to finish, from top to bottom. So you could potentially just select everything, press Command or Control Enter, and the whole thing runs for you, and there are no hiccups. That's important because sometimes you just want to quickly reproduce your analysis your analysis, and you don't want to go, you know, through each step and understanding, oh God, what do I have to do here? Oh, I forgot to read the data. Oh, I should have read the data from that folder, not from. If you just write everything out in the order that it should be run, then you can just run the entire script. And that means that if you have to make a tiny modification, for example, you don't like the colors of a plot, you want to change them, you can just simply go to the line where you create the plot and change the code there, and then you can run the whole thing and you get your nice plot. So let's try that. If you go back to analysis.r, now that we have fruit, let's plot a simple bar chart. It's not going to be anything exciting, but we can start with the data frame. In this case, the data frame is fruit, or whatever you called it, if you called it differently. Then we can use the pipe. Remember, the pipe just transfers whatever is on the left side onto the next function. And now we can use the ggplot function, ggplot. Thank you very much. ggplot function to create a plot. Remember that you need to specify the data for the ggplot function. Here, you don't need to do that because this is what the pipe is doing, is specifying that ggplot has to use fruit as the data. So you just have to specify the mapping, and that is done through the aesthetic function, through the S function. We want to create a bar chart, and we have the counts in a separate column. So we need both the x-axis and the y-axis. The x-axis is going to be the type of fruit, right? Apple versus banana. And then the y-axis is going to be quantity. If I just run this, it's going to be an empty ggplot, and plots appear in the top right corner panel. You see that I have apple and banana and quantity there. Now we need to add geometries, remember, so you do geom bar, but since you don't want geom bar to count things for you because we already counted them, you need to put stat equals identity, right? Meaning the counts are identical to the quantity column, basically. So please don't do any counting. And there we go. Now we have our bar chart with 3 apples and 1 banana. Again, nothing exciting. Now, if you close everything, or if you restart the R session, you can do that from session restart R. That is like starting from a blank slate. And I do that frequently, actually, when I do analysis to prevent issues of not realizing that I missed an important piece of code and then the script doesn't work. And if I go back in a week, I might not remember it. So I always check it straight away. And now we can rerun the whole script and the plot is going to come out for us. And there's a third way of running a script, is to use the source button that will run the entire script. But as I said before, you can even select everything and press Command Return. Both ways will work. Now I'm going to click on source, and you can see that all the code has been run here. And here we have our nice plot, right? So this is what I mean by writing standalone code, right? Is that it should be able to be run from top to bottom without your intervention. Last thing, and then we can have a 15-minute break. Well, not yes. Add comments to your code. Use comments to remind yourself why you're writing a particular code, right? And comments in R, you might have seen a few. They start with a hash sign. So, for example, no, actually, I want it here. For example, sometimes I might forget, why did I do stat equal identity? So I want to write why I'm using that. So you can add a comment like that saying using identity because the counts are already in the data, right? So this way, in 1 month, for example, you can go back and perhaps you're going to ask yourself, oh, why did I do that? And the comment will tell you, basically. And this is also helpful for other people that might have to read your code. Using comments is a way of telling them basically why you did things. There's this thing from the programming world, where comments should not tell what you did, but why you did it. Because the what, you can see it from the code, right? The what that I did was to specify start equal identity. What you might not understand from just looking at the code is why you did it, right? You don't have to follow this. It's just a nerdy rule that programmers like to stick to, but it does help, right? Because if I just right here, for example, if I just put I am using stat equal identity, well, thank you very much, right? You can see it from the code. So that's why commenting on the why you wrote a particular line of code is probably more helpful than on the what. But again, this is just a suggestion. Right. We can here, well, just a spoiler for the next part. Even better than our scripts is using our markdown files, and we're going to look at those after the break. Great, so let me start the timer. No, sorry, 15-minute break. We're going to start again at 11 if you're on my time zone, or I don't know, depending on your time zones. So see you again in 15 minutes. Right. We can start again while we wait for everybody to slowly get back to their desk. I probably should mention some clarifications because a few of those had some issues, and most of those were related to not using perhaps the right function or other things that I should have actually made clearer before. And just if you're wondering whether I'm still recording, I am, because I forgot to pause it. So you don't have to remind me. So be sure that you're using the read underscore CSV function. The read.csv is from base R, right? Remember that we talked about some functions just being available through when you install R, but I do not recommend using the base functions for reading your files, because they do weird things to some kind of columns and other things. So sometimes you might get unexpected results just because of the way the data was read into R. So I do recommend sticking to the data-viz functions, and basically all the data-viz functions will have an underscore. So if you see a underscore, is very likely a function from the data-viz, not necessarily, or a function that works well with the data-viz. So be sure that you're using read underscore CSV rather than read dot CSV. Generally, CSV files do not have spaces around commas. So do not think of this as writing normal text. This is not normal text. It's a special file, so you shouldn't be putting spaces after the comma, although that is normally what we do when we type text. Also, usually it doesn't hurt to have an empty line at the bottom. Make sure that it's actually empty. So you should just press enter, and you would have an extra empty line at the bottom with no spaces. Some editors actually do that automatically, and sorry, you're right. Let's share desktop. Thank you. Sorry for that. So as I was saying here, there shouldn't be spaces, right? So that doesn't really work. Instead, you need not to have spaces because the comma is just there to delimit the columns, right? It doesn't have any textual purpose. And then you might want to have an extra empty line at the bottom. So now we actually created a CSV file ourselves, but generally you don't do that. Generally, you either download a CSV file from the internet, or you would, if you're using an experimental setup, generally what you get is a comma-separated file, or sometimes an Excel file. There's ways of importing Excel files into R, but if you're working with R, I do recommend, if you can, to get CSV files whenever you can. So if there's an option, in the software that you're using to collect data, for example, to download the data as a CSV file, use that over Excel files. You can open CSV files in Excel and in OpenOffice, for example, or LibreOffice, if you use these, and they will look like a spreadsheet. And generally, when I need to do changes for some reason to CSV files, I open them in using OpenOffice, for example. So normally you wouldn't be working on a CS file directly like we're doing now. Yes, then last thing, in terms of styling of the code, spaces are not necessary in most cases. Spaces don't matter in most cases. In some cases they do. I can't think of anything right now, but I feel inside that sometimes they do. But I do recommend using spaces to make your code easier to read for yourself and for other people. Also, empty lines don't matter. So these is equivalent, but I do prefer having spaces because I can read the code better. Generally, you would want to add spaces before and after special symbols, like the assignment symbol, right? So here, so here I have a space around it, because again, now you know it's little code, is just a few lines, but when you have hundreds of lines of code, it does make it easier to read the code. This won't work, so there you go. That's one case where the space does matter. It has to be like that, right? Never mind that it looks like a arrow. It's the font I'm using, but in your case, it might just look as a greater than sign followed by a dash. But it's important not to have spaces between. But I do recommend spaces around. Also, going on the next line doesn't really matter, is optional. I like doing that because, again, it's easier for me to read, and generally each line does something different. So if I need to make adjustments, I can just focus on that particular line. And in fact, R is quite clever. So if you're writing something like this, I'm gonna show you again here, and you write fruit and then space and then the pipe, and now you press enter. It's when it goes onto the next line, it indents the line for you. If it doesn't, you might have to enable that in the options. It should be enabled by default. So you can just start typing straight away, and I can just type ggplot and add, what was it, fruit and quantity, right? You don't need any spaces here. In this case, this is code, is not a CSV file. You do want to add a space after the comma because it helps you reading the code, right? So in fact, think of an R script as a text, basically. You want to be able to read it well, and you want things to be tidy. Instead, a CSV file is just a CSV file, and it doesn't matter, and you shouldn't be adding spaces. So now I call this function. Another thing, let me see if there's... Yes, I will send the link to the recording as soon as it's ready from Zoom. What was I but right? Functions, they always have the parentheses. It generally doesn't matter, but make sure that there are no spaces between the name of the function and the parentheses, right? Sorry, there's a fruit fly, since we're talking about fruit. So if I do ggplot, do not add a space there, right? As a convention, there shouldn't be any spaces between the name of the function and the parentheses, right? Make sure that that's always the case. Then we know that with ggplot, we need to add geometries by using the plus sign. That is a symbol, add a space before. And I like, with ggplot in particular, I like every time I have the plus, I prefer going on to the next line, because if you write everything on one line, then you will have a very, very long line that it's difficult to read. So generally I just go, I press enter and I go on the next line. You don't need a space there because you're just going onto a new line. And then I can write geombar start equal. In fact, if you start writing start, it suggests that for you, and you can see that there are spaces around the symbol equal, right? And it automatically adds them for you, and then you can type identity. Spaces inside strings, inside double quotes, they do matter. So that will not work, right? I guess perhaps it might, but in most cases it doesn't. I think that was everything. If sometimes weird things happen, like the code should work, but it doesn't, restarting the session from session restart R, or closing our studio and opening the project again might solve them. RStudio works in mysterious ways. And sometimes you just don't see something and you're convinced that it should work and it doesn't, and closing everything and reopen everything resets everything for you, and generally things should work again. So just to summarize, underscore rather than a full stop in read underscore CSV. Be careful about spaces. In most cases, they don't make a difference, but it's easier to read code. And if you're consistent in writing the code, it's going to be much easier for you to read the code in the future and for other people to read it. There's actually a link I'll send out to you to the data-viz style guide for writing code. And it tells you for each aspect of code, it tells you what they do recommend using, and I generally follow just that. Right. So going back there we go. So we were using scripts, R scripts, but there's even a better way. So in R scripts, you can only write R code or comments, right? And remember the comments start with a hash sign. You can't do anything else. Either it's R code or it's a comment starting with a hash sign. If you write text, it's without the hash sign. If it's not a comment, R will think that it's code and will not know what to do with it, and it's gonna throw an error, right? I can show you. I am just text. And now if I run everything, error, unexpected symbol in I am, right? It doesn't know what to do with it. And you also see that the file editor tells you that there's an error. If you don't see that, again, you might have to enable it in the global options, but it should be enabled by default. So this is what happens with our scripts. Only code and comments, nothing else. Instead, R Markdown is another type of file where you can actually mix text, code, and plots and everything. So you would have in a single file, you can see everything. You can see code, you can write normal text, you can see the plots generated by your code, and much more. So in general, actually, I do not use R scripts, but I use R Markdown files. And this is exactly what I said. It has several output formats. So you can actually, once you write your R Markdown file, which has an extension, we're going to see an example in a second, but it has an extension RMD. Once you have your RMD file, your R Markdown file, you can actually convert it into a HTML file or PDF or docx for Word. I don't use Word or Excel or anything, so I never had to actually convert it into a doc file. There are some journals still, I think, that require a doc file or RTF file. Weird, but there are a few. In most cases, depending on the field, now more and more journals actually accept RMD files directly, or LaTeX files, if you ever heard of that. And actually, to go from RMD file to a PDF file, you go through a LaTeX file. You don't need to know the details. Some journals accept LaTeX files as well, and you can convert an RMD file into a LaTeX file. So it's very flexible. And let's see, there's this articles package that has templates for journal submissions. So perhaps in the humanities, it's still not particularly common. So if you are in the humanities, more like proper humanities rather than social sciences, the journal that you want to submit to might not have a template, but otherwise, generally, you might be able to find general templates that you can use. With R Markdown, you can also write books. You can write presentations. These presentations were written in R Markdown. You can write websites. My personal academic website is written with R Markdown, and you can also write blogs with those websites, so you can write posts in completely, like entirely in R Markdown. And the nice thing about R Markdown is that it has been designed to work with R, but you don't have to use it for R. You can actually write an entire novel in R Markdown without basically needing to write any code, any R code, except perhaps for just a few lines. And then you can, get very nice typeset books just by using R Markdown. So it's extremely flexible. And another thing that you can do with R Markdown is to create interactive web applications, for example. So you can really do anything with it. So I actually do recommend using R Markdown. I'm going to show you how a R Markdown file looks like. You can click on the plus file button there, and then on R Markdown, and a window is going to come up. You can change the title. Let's call it my first RMD file. And here you see that you can choose which output you would like the R Markdown to be converted to. The default is HTML, and then you have PDF and Word. I'm going to stick to HTML. You can for PDF to work, you will have to have on your computer a distribution of LaTeX or TeX. If you've never heard of that, then never mind. But we're going to stick to HTML for now because that doesn't require anything, and it's generally quicker to render a HTML file than other types of file. If you click OK, it's going to open your RMD file. And let me check, no questions, great. And let's save it. Now you can click on the Save button over there. And let's put it in code. Technically, this is text and code, but whatever. And I'm going to call it new, analysis 2. We don't need to that's interesting. We don't need 2 extensions. There we go. And I'm gonna save it inside the code folder. And this is how it looks like. So the top part, it's called the preamble, and it has this weird things. You basically have keys, and then the keys are followed by a colon, and then you have the value of that key. Remember that I called this my first RMD file, and that was the title, and here you see that the title is my first RMD file. It's a string, so it's double quoted. I am the author, so it also gives you the author, the date, and then it says that the output is an HTML document. You can make changes, so you can actually delete, for example, I'm going to delete my surname and just leave Stefano. Let me just check, sorry, how we are doing with time. You might have guessed that I'm running late, 11:45. Yes, actually there is no tutorial for this part. It's basically just live coding and showing you on RStudio. There's a tutorial for tidy data that requires some input from you, but it's quite short, if I remember correctly. And then the advanced skills tutorial, it's just like showing you what you can do, but you won't be able to actually run, to actually interact with the code much. So R Markdown, this is how it looks like. What you see here, it's a code chunk. They're called code chunk, and they are chunks that contain R code, right? So you would write R code inside code chunks. Chunks in R, they all start with 3 backticks. Depending on your keyboard, they're going to be in a different place. If you have a American layout, they're usually in the top left button where the tilde is too. So it's going to be a button that allows you to get those two. If it's a European layout, it might be to the right of the Shift button, but I'm not quite sure. And by European, I mean basically all keyboards with from European languages. It tends to be the same. But sometimes you have a key that you can press in that position, but the symbol is somewhere else. So you have to check you have to check your keyboard to find that. But code chunks, they all start and end with 3 backticks. And in R, you also have curly brackets and then R. So you see that as soon as I've added the R thing, you see some controls appearing in the code chunk. If there is no R there, there are no controls. So generally, you would want to put the R there to tell RStudio basically that that is code that can be run, right? There's actually a shortcut from the keyboard, so you don't have to type that. On Mac OS is Option Command I, and we get the nice thing. It could be Control Alt I on Windows. If anybody can confirm that, it should work. And you can just type that. You can just press those buttons, Option Command I or Control Alt I on Windows, and that will fill the code chunk for you. It's going to create a code chunk for you, so you don't have to type things manually. So this is the setup, the setup code chunk that is added automatically when you create a new R Markdown. That is where you would normally add your libraries, for example. So you can do library tidyverse. Don't mind this line. I'm not gonna explain what it does, but you can read everything about R Markdown in the links that I added in the last part of today's session. So you can add library tidyverse, for example, and that will load when you run the code. It will attach the package, and of course you can add many more. For example, let's do LMF4. Never mind. So normally you would add the libraries that you need in the setup chunk. Then what you see here is actually normal text, but it uses a specific syntax, a specific markup language to style the text. So, for example, if you write a line of text preceded by 2 hash signs, this is not our code, so these are not comments. That actually means heading of level 2. If you want a heading of level 1, so my main heading, you would do that. And with level 3, you do this. This is level 3. I'm not going to go through everything in Markdown. There's a lot of tutorials online, so this is just a brief overview. If you use 2 stars before and after a word, that word is considered to be bold. If you just use 1 star, that's considered to be italics. The way you can run this, there are several ways. One is just to click the green arrow. Let me check if there are important questions. Yes, so Control Alt I works on Windows. That's great. If you click on the green arrow over there, it says Run Current Chunk. You can click on that, and that will actually run the code in that particular chunk. The code is run, and you see that it's running actually in the console rather than directly in the RMD file. But let me start the session now again. I'm going to restart the R session, Now you will see output actually appearing in the R Markdown file. No, you won't, because of course there's include equal false. Never mind, I'll show you in a second. Now I have run my setup chunk, and now we can run the cars chunk. The thing that follows the R, you do need a space there. It's the name of the chunk, and it's a good practice to name code chunks. Here, if you press the green arrow, it's gonna run that function summary, and cars is a data frame, right? You don't see it because it's attached automatically when you start an R session, and summary just gives you summary measures from that data frame, right? And the output is shown rather than having to look at the console. You can also see it there, but it shows directly in the RMD file, right? And that also works with plots. So if you run code that plots something with a green arrow, you will see the plot directly in your file. That's very convenient, right? Because you can mix normal text, code, and also see the output of the code directly in the same file. Then let me see, that should work. Then if you are ready to render the file from an RMD file onto a HTML file, remember that the output is HTML, you can click on the knit button, and it might ask you to install things. If it does, say yes. If you see that it's taking too long, then leave it there and attend to it later. But if everything works fine, you should see a window with the HTML file. Now, you can even open it in your browser if you click on Open in Browser. So this is precisely our RMD file rendered to a HTML file. And if you remember, I told you that adding 1 star before and after a word makes it italics, and there you go. This word is in italics, and if I want to make it bold, I can just add 2 stars again, nice again, and now the word is bold. There's many more things that you can do in terms of styling the text. Again, I'll point you to resources. I'm not going to go through them all now. You can actually write a paper, as I mentioned, a full paper in R Markdown. If you're using R, it's convenient because you can just write the code in your paper. The code can be hidden. So if you don't want to show the code, you can actually hide it in the output file. Now we're showing it, but you can hide it. And instead you can only you can show only the output, for example, the plot. You can write your entire dissertation. That's what I did, for example, with my PhD dissertation. I wrote it entirely with R Markdown, and everything was basically inside my project folder, text, code, data, everything. And the whole dissertation was a RStudio project and a R Markdown document. There's, again, many more things that you can do. This is just a brief overview, but I do recommend using R Markdown files over R scripts because having the ability of writing text that can be styled and having the ability of rendering the file into a file type that is nicer and easier to read is actually a convenient thing. Right, so that, I think, where am I now? Let me see. Yes, sorry. So just briefly, I do recommend separating data from code text. You've noticed that we have created a data folder and a code folder in our project. I generally do that for all of my projects. I separate data from code. In terms of naming, I recommend, I actually very strongly suggest not to use spaces when naming files and folders. You can either use the underscore instead of a space. It's for several reasons. I'm not going to go through them, but it's going to save a lot of time in the future if you don't add spaces. And generally, I do not use capital letters when I name files and folders for the simple reason that it's quicker than to type. If you need to type the name of the folder and the file, unless you're using automatic completion in RStudio, but in any case, it's easier to type if it's just all lowercase. And it's common practice in programming and computer sciences and statistics actually to use always lowercase letters. You might want to separate raw data from derived data. So, for example, if you run an experiment and you download the data, you might want to put that in a raw, in a folder named raw inside the data folder, and you might not want to touch that ever again. That helps you actually preserving raw data and avoid basically making changes to it and that not being able to get the original data. And then you can have a separate folder called derived, for example, where if you're transforming the data in any way using R, for example, R code, then you can save the output of that transformation into the derived folder. Treat raw data as read-only, right? Like think of raw data that you get either from the internet or from your experiment as something that you only read into R, but you don't change. So the CSV file with your raw data should never be changed manually, right? You should only do that with R after you import the data and save it into a different file. If you've never heard of versioning, I do recommend that as well, especially if you will use R a lot. Versioning simply allows you to keep track of all the changes that you're doing, that you're making to your code, your text, your data, everything. And it remembers all of the changes that you've done, and you can roll back if you, for example, realize that you made a mistake, or whether perhaps you want to go back to a previous analysis, you can actually roll back in time. I'm not going to have time, of course, to teach you about versioning systems, but I do recommend looking up Git, GAC, and GitHub. They work well together. Not going to summarize this. I think we have repeated a few things and seen some things a few times. So that's all for the first part of today's session. And now it's 11:33, which gives us 10 minutes. What I can do is to, I completely forgot that I put this picture and they're really cute. We can check, now should be tidy data. Yeah, so what I'll do now is move on to the next topic. Unless there are questions that you want to ask now about what we've seen so far, I'm happy to answer those, or we can move on to the next topic, which is tidy data. So I'm gonna stop sharing that. And I'm gonna share that one, I guess. Yep. Right. So what is tidy data? Sorry. So tidy data, as it says here, is a standard way of mapping the meaning of a data set to its structure, basically to its columns and rows. The slides that you're going to see, the next few slides, are from Alison Host. Brilliant, like she makes brilliant illustrations related to R. They're really wonderful. And in going back to tidy data, a data frame or data table is tidy if each variable is a column So in this example, you see that you have an ID column, a name column, and a color column. And each of this is a variable in the data table, right? And then each observation forms a row. So each row should be one single observation. And in this case, you have Floof, Max, Cat, Donna, Merlin, Panda with the color for each individual observation, basically, or item in your data frame. And each cell is a single measurement, right? So the cell, the first cell under name is Floof, and that is only the name of that particular observation. You don't have any other piece of information there. And if we go to ID 3, the name is cat and the color is orange. So tidy data has one column, one variable, ID, name, color, one row, one observation. This is a gray Floof. This is black Max, orange cat, and so on and so forth. And each cell ideally contains a single piece of information, a single measurement. So the standard structure of tidy data means that tidy data sets are all alike, right? Because they all follow this particular standard structure, which is variables are columns, observations are rows, and measurements are cells. But every messy data set is messy in its own way. So tidy data sets are all alike, but every messy data set is messy in its own way. And most data frames that you find either on the internet or data frames that are output by software, for example, if you have more experimental methods, they tend most times not to be tidy, meaning that when you download them, then you need to make them tidy in order to use them efficiently. So the tidyverse, that's why it's called tidyverse. It's like the universe of tidy data. And the tidyverse has a few functions that allow you to tidy up the data. And here it says more on untidiness, that when you work with tidy data, you can use the same tools in similar ways for different data sets. That's the principle of the tidyverse. You have that particular structure, and that will allow you to use all of the functions in several different data sets. So once you learn how to use one function, that will work with all data frames, basically. While if you work with untidy data, means that you will have to create ad hoc solutions, one-time approaches, and then it's hard to use that particular approach to a different data set, to apply that to a different data set. Tidying up the untidy data, it's called wrangling, wrangle. It's very small, but it's written over there. So when you have untidy data, you can wrangle the data using tidyverse functions, and that will give you tidy data. Before moving on to the functions that will help you actually tidying up data, I want to briefly talk about wide data tables and long data tables. These terms are relative. So in fact, you can have a wider data set or a longer data set. There is no absolute measure of saying, oh, this is a wide data set and this is a long data set. It depends on the data itself, on what there is, what kind of data is in the table. But if you compare these two data tables, they have exactly the same information. They have exactly the same data. Here you have a ID column 1, 2, and then you have X, Y, Z. Think of those as 3 different things. It could be, I don't know, child, adolescent, and adult. And this could be number of messages sent per day, and that could be number of posts posted online, for example. And then you have, for each combination, you have the measure, right? So this is wide and this becomes long because you can see that this has four columns and 3 rows, while this has 3 columns and 6 rows. So that's why this is long. And if you look at it, like it does look longer, right? And this instead looks wider. So again, it's a matter of relative size. When you go from more columns to less columns and less rows to more rows, you generally go from wide to long, and vice versa. There are 2 functions in the tidyverse. They're called pivot longer and pivot wider. Pivoting is the process of conversing from a wide format onto a long format, and vice versa, right? So sometimes you might get data that is in a format that for you is a wide format, but you need a longer format. So you can use the pivot longer function to transform the data from wide to long. And sometimes it's actually the other way around. You might get data in a long format, but you need it in a wider format. So you can use the pivot wider function. This just shows you visually what it means to use pivot longer and pivot wider. Never mind what you have to put. It's in the tutorial that we're going to do after the break. So this is a wide table for A. You have country, you have 1999 and 2000, right? But if you want to plot this, and if you want to plot, for example, a line plot by year has to be a column. Remember, like it needs to be a variable. It needs to be a column in the data table. Here instead, it's not. You don't have a column called year with 1999 and 2000. Instead, that piece of information is in the name of the column itself, and you have 2 separate columns. So you want to make this longer, right? You want to transfer the information about the year into its own column. So you can create a year column and then the number of cases. This is number of cases that had the flu, I think, somewhere in 1999 and 2000. So you transform this wide data table into a longer data table. And you can see that the colors match basically the different pieces of information. So you have 1999 in light green over there and 2000 in darker green, and the same for the measurements, right? So pivot longer transforms a wide table into a long table. Then you can do the other way around, of course. If you have a long data table, you can transform it into a wider data table with pivot wider. And you might need that because, for example, in this case, you have for each individual year, it tells you the type of measurement. Either it's the number of cases out of the population that got the flu, and then you also have instead the total number of population, right? So that you can compare how many people within that population actually caught the flu. If you want to plot, for example, cases against population, right, and compare them, you need cases to be in one column and population in a different column. So you can use pivot wider to go from the table 2, from the longer format to the wider format. That's everything that there is basically with pivoting. It's just transforming the data from a wide format onto a longer format, or vice versa. Yes, so briefly, there are 2 other helpful functions. One is unite and separate. These work with columns. So for example, here you have a table that has century and year as 2 separate columns, but in fact you just want one single column that is called year with the year. So you can use unite, the unite function, to unite these 2 columns into a single column. Sometimes you might want to do the opposite. You might want to separate one column into two or more columns, because, for example, one cell does not contain only one measurement, but contains more than one measurement, and you want to split it, so you can use the separate function. So in brief, there's pivot wider, pivot longer, unite and separate. Those allow you to tidy up untidy data. So we can have a break now of 15 minutes, and we can do the tutorial after the break. Great. Nice. So we are starting about the last part for today. We have 30 minutes. I invite you to start working on the tutorial for the tidy data session. So if you let me share our studio again. If you go back to our studio that you were using before actually creating a new project, or you're more than welcome to keep on using the RStudio project that you created. You can open the tidy data tutorial. For those who couldn't open the tutorial from RStudio, you can attach the intro library, and then you can do intro _ tutorial. No arguments, you press enter and it asks you which tutorial to run, and you can select 6, and that should open up the tutorial for you in your browser. It shouldn't be too long. I can't really estimate that. But what we can do is in 25 minutes, about 25 minutes from now, I'm just gonna basically close today's session and tell you what will happen briefly, what will happen on Friday. If it happens that you finish this tutorial before 25 minutes from now, then you can do the 7th tutorial, because for that part, my plan was to let you first do the tutorial and then I would do the presentation. So you can go ahead and start working on the tutorial 6. If you have questions, you can ask them on Slido. And if you finish before about 25 minutes from now, you can keep on working on the tutorial 7. Right. So if you're struggling with the pivot section, and there's one chunk that there's one code box that you're sure that it's correct and you're running it and you don't see anything, it's because the output is saved into a variable. So you don't see any output in the code chunk. But if you add, sorry, in the code box, but if you add the name of the data frame and then you run the code again, you will see the output of the data frame there. So when you don't see anything happening in these tutorials, it's because it worked, but you just don't see any output because there isn't any output to see. If something went wrong, you generally get an error message. So if you don't see anything, generally that means that the code is fine. We can keep on for another 5 minutes, and then I'll just finish off with the last slides. Right. So with 5 minutes to go, I'm aware that there are some of you who are experiencing some issues with either packages or some of the code. I'm not going to be able to address them right now. What you can do is to send me an email instead, and perhaps I'll either reply to the email with the solution directly, or I will go through that on Friday if you're joining on Friday. So if you're still working through the tutorial number 6, that's absolutely fine. And basically what you can do is you can keep on working on the tutorial 6 and 7 at your own time. And if you have questions, you can write to me. I'm particularly busy this week, so I might reply to you later, but feel free to send me an email. I'm just going to quickly tell you what the tutorial 7 does. And it's basically a show reel of other things that you can do with that. The first one, actually, it's quite important. It's called faceting, and that allows you to separate data into different panels, like this one, for example. You did see some of the Harry Potter data. In this case, I'm separating the different houses and plotting the number of people depending on the astrological sign, right? And with faceting, you can split the data, in this case, into different houses. Maps, with maps, they do require the data to be in a particular format, but if you go to the website that I link, it's quite good for beginners as well. And with what you learned yesterday and today, you will be able to follow along, and you can create maps with that. I'm sorry if I didn't have the time to actually go through this more. But with the limited time, I could do as much. Here you have also mosaic plots. They can be helpful when you have discrete categorical variables, like for example endangerment status and macro area, where the languages are spoken in this example, and those are good for visually assessing different numbers of observations within the individual variables. Questionnaire data, Likert data, for example, they can be visualized using these so-called diverging stacked bar charts. They do require some data wrangling and transformation, but it's nothing that you haven't seen yesterday or today, or that you cannot understand just by reading the links that I provided. So this is particularly helpful for questionnaire data, for example. Then this is simply grouping and summarizing the data. Sometimes it's helpful, you can use the function summarize to summarize data based on groups that you specify with group by. So for example, you can get the number of people in each house and element from the Harry Potter data set. This basically, both grouping and summarizing and faceting are covered in the R for Data Science book. I strongly recommend you to have a look at that. In fact, most of the ideas of this workshop come from this particular book, and it guides you through everything that we covered today and more that yesterday and today, and more that we didn't have the chance to go through. And basically everything that you want to know about the tidyverse packages is in this book, so I do recommend having a look at it. Then there's also another book, Exploratory Data Analysis with R. This is more focused on ways of doing data analysis, and it touches upon statistics as well a bit. I do recommend looking the data-viz website, and Studio Education. It has a few tutorials. There's this other book on R Markdown, the definite guide. It really shows you everything that you can do with it. And if you're curious and you want to create your own tutorials like these ones, I use the package learner. So you can check the website if you want to create your own tutorials. That is basically everything in terms of what we're going to do on Friday. Sorry, let me bring the correct one. There we go. There are more resources. I'm linking to more resources on the slides for the 7th part of today's session, and the slides can be found on the main intro website, and also the link to the package. There's several links that are also in the tutorial, plus more. And what we're going to do on Friday is a hands-on session, which means that you can bring your own data, or you will be able to use data sets that I provide, most of which are the ones that you've been using in the tutorials. And I will give you prompts every like 5 or 10 minutes saying, now you can try and import your data. And the idea is that for you to go through from importing data to transforming data and plotting data. So if you do have some data with you, you can bring that. And you can pick whether you want the early session, whether you want to join to the early session or the late session. They're going to be the same. So you can just pick one. I'll send a Zoom link in the morning. It's going to be the same for both sessions. And so you can just join in to whichever session that you prefer. Again, sorry if I couldn't address everybody's problems. Please do send me an email if you want to try other solutions. And thank you again to everybody. I hope to see you on Friday, and I hope that you enjoyed learning about R if this was the first time, and if it wasn't the first time that you were using R, I hope that you learned some new skills, and I wish you the best, and hopefully I'll see you on Friday. So thanks, everybody.